Okay, so that's some background, and what we're going to do is try and develop some understanding of how should we think about risk. It's really important for finance, clearly. What do we need to do? Well, we're going to start out by developing some statistical measures. As we saw in Table 2, statistics is a very useful way of thinking about things. So, let's look at that next. So, the basic statistics that we need is not very extensive, but you need to understand it well. When we start talking about portfolio risks, you need to have a good intuitive understanding of these measures. Now we're going to be thinking about investing in stocks and forming portfolios. So we're going to be interested in random variables of stock returns. Okay, so if you buy a stock today, you don't know what the return over the next year is going to be. A year from now, you'll know. It'll be determined. We're going to note that X. And we're going to think of the world as having different states. To keep things simple, we're going to start with discrete states. We could also have continuous states, but let's just have two states of the world. We can have the stock X, and we're going to talk about the realization, the outcome of the stock. State 1 is a good stock, which its return is 3%. Stock 2 is a not so good one at 1%. The probability of each state, okay, clearly you're going to want to know what's the relative frequency or what's the probability of each state. We're going to note that PI. We're going to take that to be 0.5. What do we know about probabilities? There are two important features that we know about them. From 0 to 1, they've got to be between those. And what are they? What's the second one? Sum to 1, yes. So that's what we know about probabilities. Now, the next thing that we need to know something about is expectation. So what is expectation? Well, expectation is when you weight by probabilities and then you sum up across states. So if we've got the expectation of our random variable x, and we're talking about discrete states, it would be the sum from 1 to n, if we've got n states, of pi times xi. If we've got continuous states, we're going to have an integral, so the mathematics is just more complicated. But with discrete states, which we'll be illustrating things here with, it's just sigma pi xi. We've got ex squared. We've got sigma I equals 1 to n of pi xi squared. If we've got efx, then we've got sigma pi fxi. So if we go back to our previous one, we can calculate the expectation for x, And that's going to give us the mean or the average. We have a number of different notations for that are used. We have EX, which is what we're going to focus on, but you'll also see it written X bar, and you will see that it's sigma pi xi, as we said. In our example, we can work out pi xi. We get 0.5 times 3, which is 1.5, 0.5 times 1, which is 0.5. So the mean is 2. Does everybody see that? Now, if we buy a stock, we're not just interested in the mean. What else are we going to be interested in? The variance, the risk. So let's look at the variance. What's the definition of a variance? So wait a minute and we'll give it that. That's the correct answer in a minute. So how do you calculate the variance? Go ahead.
The sum of the square difference between the different states and
Yeah, so what we do is we go to each state, we look at the deviation from the mean, and then we square it, and then we weight by the probabilities and add up across states. So in other words, we're taking the expectation of x minus EX, and then we're squaring it. You'll also see that as the variance of x. That's how we're going to write it. In the book, they write it sigma x squared. And the way that you calculate it is it's the sum from 1 to n of pi xi minus EX squared. So in our example, the variance of x is going to be 0.5 P1, and then we've got x1, which is 3, minus the mean, which is 2. We square it. It's 1. 1 squared is 1, of course. And then we've got the second state, so we've got 0.5, and then we've got 1 minus 2. We square it, so we get 1 again. You add those two terms, you get 1. If we spread things out, what happens to the variance? It goes up. Just look at a quick example of that. Let's suppose we've got x star. We've got 4 and 0 instead of 3 and 1. So EX star is going to be 2 again, half times 4 and a half times 0. The variance is going to be a half. Now we've got 4 minus 2 squared, and then we've got a half times 0 minus 2 squared. We've got 4. Okay, so now we've got diagrammatically the following going on. What we've got is
second variance.
second variance is 4. So we've got 4 minus 2, which is 2 squared, which is 4.
Okay, so I didn't see that you put the next column.
Yeah, sorry.
Star column. Sorry.
No problem. So we've got 2 as the mean for our x, and then 1 and 3. That corresponds to a variance of 1. We're more spread out, so we're at 0, 4. Then the variance of x star is 4. What are the units of variance if we're talking about stock returns in percent? It can be percent squared because we're squaring everything. It's often useful to have a measure of risk which has the same units. What is that? Standard deviation. And how do we find it? Square root of variance. So the standard deviation of x, that's how we're going to denote it. In the book, it's sigma x. It's just the square root of variance. We've got the standard deviation of x in our example is the square root of 1, which is 1. And the standard deviation of x star is square root of 4, which is 2. How do we measure how things move together? Well, that's this idea that we talked about earlier of covariance. We're going to have two random variables, x and y. What's the definition of the covariance? Two stocks, x and y. Well, we're going to go state by state again. So we go to the first state. We look at the deviation of stock x from its mean. We multiply by this deviation of y from its mean, and then we take expectations. So we multiply by probabilities and sum. And in our discrete example, it's going to be the sum from 1 to n of pi xi minus ex yi minus ey. Let's look at some examples. Suppose we've got two states still. We keep xi the same, so it's 3 and 1. Yi is 6 and 2. The probability of each state is 0.5. Ex is 2. You work out Ey, it's half times 6, which is 3, plus a half times 2, which is 1. So here we get 4. So the covariance of x and y is going to be 0.5 if we're in state 1, times 3 minus 2, the deviation of x from its mean, times 6 minus 4, which is the deviation of y from its mean, and then we've got 0.5, 1 minus 2, and 2 minus 4. If you work that out, it's 2. The key point is that when x is above its mean, what do we know about y? It's above its mean. So we've got a positive term times a positive term, which gives us positive. Here we've got x below its mean, so we get a negative. Y is below its mean, so we get another negative. Negative times negative is a positive. So if things are above the mean and below the mean together, we get a positive covariance. Let's just change things slightly by swapping the 6 and the 2. So we've got 2 and 6. Now we've got the same calculation, except this is now a 2 and this is now a 6. If you work it out, the covariance of x and y in that case is minus 2. What's going on? Well, when x is above its mean, what do we know about y? It's below its mean, so we get a negative. Positive times a negative is a negative. Here we get a negative times a positive, and that again gives us negative. So what's happening here is we've got x above, y below. We get negative terms as a product, and when we've got x below, y's above. So negative means they move in opposite directions. Are there any questions on that? Yes.
What does VE stands for?
Sorry?
What does VE stands for? Plus or minus?
So if we've got plus and then the VE, it's positive. And minus VE is negative.
What does it mean?
It's the end of positive and it's the end of negative. So that's how people often write positive. Is that a distinction? It says here writing POSITIVE.